So our aim today is 9.4, reciprocals and ASTC. So what is a trig ratio? Ratios of the side of a triangle are called trigonometric ratios. A mnemonic device to remember this is SOHCAHTOA. Whether a side is opposite or adjacent depends on the angle's perspective. So we have angle A here, and depending on your perspective, that will determine which side is opposite and which is adjacent. So notice here that the adjacent side is AC because it's the side that's next to angle A. The hypotenuse is always opposite 90 degrees. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what is sine A? Looking from this perspective, the opposite side is 3, while the hypotenuse is 5. Reciprocal trig ratios. Reciprocal trig ratios is a flipping of a fraction. So instead of A over C, it's now C over A. Notice how we've replaced the words hypotenuse, adjacent, and opposite with A, B, and C. Cosecant is the reciprocal of sine. It is C over A. The reciprocal of cosine is secant, C over B. The reciprocal of tangent is cotangent, B over A. Reciprocals can also be written in terms of their reciprocal. So secant is equal to 1 over cosine of theta, cosecant of theta is equal to 1 over sine of theta, and cotangent of theta is equal to 1 over tangent of theta. Now let's talk about how a coordinate is determined. Coordinates are an ordered set of numbers that determine the position. The x-coordinate tells where the point is in the left and right direction, and the y-coordinate tells what it is in the up-down direction. So if you notice here, we have a right triangle that's been drawn. Now, what is the coordinate of the green point? Well, it's gone x units over to the right and y units up. Therefore, its coordinate is xy. Now, according to this, what would be cosine of theta? Cosine of theta is adjacent over hypotenuse, so x over 1, or simply x. And the same goes for sine, however, it's the opposite of the hypotenuse, y over 1, or simply y. Therefore, our coordinate xy can also be rewritten as r cosine theta, r sine theta, in which r represents the radius. So this is a recap of a previous lesson in which we derived the coordinates of the unit circle along with the degrees and radians that they correspond to. So for practice, notice at 150 degrees, our coordinate is -3 rad 2, comma 1/2. So at this part, what is sine? Well, sine is 1/2. Notice how in the second quadrant, your y values are positive and sine controls y, so sine will also be positive. Cosine of 150 is negative square root of 3 over 2. At 240, we have the coordinate -1/2, negative rad 3 over 2. Notice in the third quadrant, both x's and y's are negative. Cosine of 240 is negative rad 3 over 2, and cosine of 240 is -1/2. Now we have 315. Here, our sine of 315 is negative square root of 2 over 2, and our cosine is rad 2 over 2. And at 270, our sine, notice here that no right triangle can be drawn. So our sine here, according to the coordinate, is -1, and our cosine will be 0. And we can also derive this using right triangles, drawing right triangles from these points to the x-axis, as I'll show in the next slide. So now we're going to derive sine and cosine for 150 degrees. So if you look at 150 degrees on your unit circle, we're going to create a right triangle. So I'm going to create a perpendicular line right here. And if you'll notice that the reference angle here is 30 degrees. So I'm going to make this 30 degrees because our reference angle is also 30. 150 is 30 degrees away from 180. So we know that our hypotenuse is 1, which is also the radius. However, if you recall from a previous lesson, the side that is opposite 30 degrees is always half that of the hypotenuse. So this is 1/2. And by the Pythagorean theorem, we would have obtained that the side that's opposite 60 degrees is the square root of 3 divided by 2. So when we perform our cosine ratio, cosine of 30 degrees here would be adjacent over hypotenuse. So the cosine of 150 degrees is equal to the square root of 3 over 2 divided by 1, which is simply the square root of 3 over 2. Now for sine is opposite over hypotenuse. So the sine at 150 degrees is 1/2 divided by 1, which is simply 1/2. However, notice where we are. Since we are in the second quadrant, our x values in the second quadrant are negative. So we're just going to put a negative there. That doesn't mean the side is negative, but the negative is used as a way of determining where you are in terms of the unit circle. So negative rad 3 over 2, that would make cosine here negative rad 3 over 2. And if you'll notice from our previous slide, that would be the coordinate right here, rad 3 over 2, negative rad 3 over 2, 1/2. So now let's move on to 240. Now for 240, you're going to be right here. So I'm going to make a perpendicular line over here. And the reference angle here is 60 degrees. So if I were to make a reference angle, notice these two have point symmetry. So this is really 60 degrees. Again, this is 1 because it's in the unit circle. So if this is 60 and this is 90, this side here must be 30. And the side that's opposite 30 is half of the hypotenuse. So this is 1/2. And this side over here, by way of the Pythagorean theorem, would be the square root of 3 over 2. However, since we are in the third quadrant, both x's and y values are negative. So I'm going to put negatives in front there. So now we have cosine of 240 degrees is equal to adjacent over hypotenuse, and in this case it would be negative 1/2. And sine of 240 would be negative square root of 3 over 2 divided by 1. So now let's move on to the circle that is 315 degrees. So for this particular angle, the reference angle is 45 degrees. Notice the 45. So I'm going to also draw 45 degrees here. This is still 1. Now from a previous lesson, we derived that when you have an isosceles right triangle and the hypotenuse is 1, your sides would be the square root of 2 divided by 2 and the square root of 2 divided by 2. However, since we're in quadrant 4, your y values are negative, so I'm going to put a negative in front there. So cosine of 315 degrees is the square root of 2 divided by 2 over 1, which is just the square root of 2. And sine of 315 is equal to the negative square root of 2 divided by 1, which is the negative square root of 2. Again, it still follows that as coordinates, this would be the square root of 2, rad 2, and negative square root of 2 over 2. So now we get to 270. So at 270, you'll notice we have no triangle that is formed because there is no movement horizontally. So since there's no movement horizontally, there is no adjacent side. So your adjacent side here, cosine of 270, your adjacent over your hypotenuse, well, there's no adjacent side, so it's 0 over 1 because the hypotenuse is still 1. And your answer is 0. However, for the sine values, since this is the unit circle, this has a length. Your opposite side, if we were to look from a reference angle, your opposite side would have a distance of 1. However, since we're in between quadrants 3 and 4, and sine is, your y values are negative there, sine of 270 is negative 1 divided by 1, which is negative 1. Okay. So now, let's move on. So, of note, tangent of theta is equal to opposite over adjacent, or y over x. And that is equivalent to sine of theta divided by cosine theta. Now, why are trig ratios positive? Well, in the first quadrant, both x's and y's are positive, so all of the trig ratios will be positive. However, in the second quadrant, only y is positive, therefore sine and its reciprocal, cosecant, are positive. In the third quadrant, both x's and y's are negative, therefore tangent of theta will be positive because it is sine divided by cosine, or y divided by x, along with its reciprocal cotangent. They're both positive. In the fourth quadrant, just x is positive, therefore cosine and secant are positive. A nice way of remembering this is the mnemonic all students take calculus. So in the first quadrant, all are positive. In the second quadrant, sine is positive. And in the third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. Additionally, from our originally drawn triangle, we can derive the Pythagorean theorem, x squared plus y squared is equal to 1 squared or 1. But we can replace x with cosine of theta, and we can replace y with sine of theta. Therefore, we can rewrite that as cosine squared of theta plus sine squared of theta is equal to 1. Of note, sine squared of theta, in parentheses squared, is not the same as sine of theta squared. One squares the ratio, while the other one squares the angle. However, sine of theta squared, when it's in parentheses, is the same as sine squared theta. Your homework tonight is delta math. Scrap paper is required for the portion that says find sine or cosine using an identity.